So the curve C in the standard Cartesian plane is defined by the equation x equals 4 sine 2y. The curve C passes through the origin. Part A says we need to find the value of dy by dx at the origin, and this is for 2 marks. So I'm just going to write out our equation here. We've got x equals 4 sine 2y. And the first thing I notice is actually we've got x as a subject here instead of y that we'd be used to. So what we're going to do, instead of finding dy by dx, we're going to find dx by dy. So we're going to differentiate everything with respect to y. So we're going to get dx by dy equals, I'm going to have 4 here, multiplied by, if we differentiate sine 2y, we'll get 2 cos 2y. So this equals 8 cos 2y. This is great, however, we need to look at dy by dx, but we've got dx by dy. So what we're going to do is take the reciprocal of both sides. So if we do that, we're going to get the dy by dx that we want on the left hand side, and it's going to be 1 over everything. So 1 over 8 cos 2y on the right hand side. So now lastly, we need to find the value of dy by dx at the origin. So at the origin, it's 0, 0. So x equals 0 and y equals 0. So we're going to sub y equals 0. So doing that, we get that dy by dx equals 1 over 8 cos. And that would be 0 because 2 times y, when we're subbing y to be 0, just goes to 0. Putting that into the calculator, we find that cos of 0 equals 1. Therefore, the value of dy by dx at the origin equals 1 over 8. Therefore, the value of dy by dx at the origin equals 1 over 8. So we'll get 1 mark here for all of this working here. So attempting to differentiate x equals 4 sine 2y, and then taking the reciprocal, so inverting it to get dy by dx. Then we get the second mark here for realising at the origin it's going to be 0, 0, and subbing that in and getting dy by dx equals 1 over 8. So part B1 says, use the small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. Okay, well, our small angle approximation is that when sine x for values of x that are small is approximately equal to just x. So it follows that for sine 2y, for small values of y, would approximately be 2y. So therefore we say x equals 4 sine 2y. And then using sine 2y is approximately equal to just 2y. So use that, we can say that x is approximately equal to 4 multiplied by 2y. So x is approximately equal to 8y. And that's the final equation linking x and y. For the second part B, we need to explain the relationship between the answers to A and BI. So the value found in part A is the gradient of the line found in part B, part 1. So what we're saying here is that 1 over 8, so what we found in part A is the gradient of this line here. And that would make sense, because actually if we rearrange this to get y equals 1 over 8x, then we can see here that our gradient is 1 over 8, so it makes sense. So in part B, you get 1 mark for this working here, so getting down to x is approximately equal to 8y, and then you get the second mark for this statement right here. Lastly, we're going to take a look at part C. So we need to show that for all points x, y lying on C, dy by dx equals 1 over a multiplied by the square root of b minus x squared, where a and b are constants to be found. And this is for 3 marks. So what I've done here is I've written down some things we worked out in the previous part. So we know that dy by dx equals 1 over 8 cos 2y, and x equals 4 sine 2y. So this is what we're going to use. We're also going to use one other identity. So we know that sine squared x plus cos squared x equals 1. However, it then follows, if we replace all the x's with 2y, we're going to have that sine squared 2y plus cos squared 2y equals 1. So we're also going to use that identity. And using these 3 things, we're going to get dy by dx in that form. And the thing I noticed about this form is we've got dy by dx, and then we just got x's here. So essentially our aim is to eliminate all of the y's from the right hand side. First, I'm going to work with this and this. So if we square this equation here, we're going to get that x squared equals 16 sine squared 2y. This is great because we've got a sine squared 2y here and sine squared 2y here in this identity. So we can use that to get cos squared 2y instead. So using, and if we rearrange the identity, we're going to get that sine squared 2y equals 1 minus cos squared 2y. We can now say that x squared equals 16 multiplied by 1 minus cos squared 2y. So therefore x squared equals 16 minus 16 cos squared 2y. What I'm now going to do is try and make cos squared 2y the subject. So I'm going to add 16 cos squared 2y to both sides and take away the x squared. So we get 16 cos squared 2y equals 16 minus x squared. If I just divide by the 16, we'll get 1 minus x squared over 16. And if I square root both sides, I'm going to get that cos 2y equals the square root of 1 minus x squared over 16. It's fantastic because we've now got an expression for cos 2y. So we're going to go up here and we can use that. So we're going to work with our dy by dx expression now. So we're going to say dy by dx equals 1 over 8. And we can see here it's 1 over 8 cos 2y. But we know what cos 2y equals, so we're going to replace it with that. So 8 multiplied by the square root of 1 minus x squared over 16. Fantastic, we're getting really close. But if we look up in the question, we can see we need to work a bit to get it in different form because we've just got an x squared here instead of x squared over 16. So I'm going to times both the top and the bottom by the square root of 16. This will mean we get root 16 on top over. I could choose to multiply the root 16 either by the 8 or by the square root here. But if I do this, we're multiplying both the surds together. So we're going to get 8, and then we're going to get the square root. So we get 16 times 1. So we get 16 here. And then this is the crucial bit that here, the 16s cancel. And so we're just left with x squared as it wants in the question. The last thing to do is actually that this just equals 4. So if we divide the top and the bottom by 4, we're going to get 1 over, and then 8 divided by 4 is just 2. So 2 square root of 16 minus x squared. And then we're finished because that's in the form that it wants in the question. So we've got that a is 2 and b is 16. So look through, we get 1 mark here for all this working down here in an attempt to get dy by dx to have no y's on the right hand side. We then get the second mark for this bit here. So for getting correct answer for dy by dx. And then we get a final mark right down here for going through these steps to simplify it down into the form that they want.